Hello student, I am Arnab Das. Today again we meet together for continuing our topic relate amplifier. Today we discuss about the class B and the class AB type of amplifier. For the class AB type of amplifier we already know that it operates in the linear region for the 180 degree of the input cycle and is in cutoff for 180 degree. For the AB type of amplifier, biased to conduct for the slightly more than the 180 degree. Both are so effective for the efficiency one, and for this reason this is more better than for the class A type of amplifier. But there are also little bit some disadvantage, and for this reason this one can be recovered by using push pull type of configuration. For the class B type of amplifier, they are due to the reason of that bias is at the cutoff point so that ICQ, that is the Q point collector side current, is 0, and that time VCQ will be equal to a VC on cutoff condition the voltage drop. It is brought out the cutoff and operate in its linear region when the input signal drives the transistor into the conduction. That means here only the portion of half of the input, positive half of the input, will be used as the output one for a class B type of amplifier. That means the circuit, if you consider on here, this is also can be defined as a emitter follower circuit where input is applied through the base terminal and the output is collected from the emitter side, from this portion. This is collected. So here the portion of the positive peak only coming as the output one in this position and not amplify the entire cycle for the input one on there. For the class B push-pull type of amplifier, there are two common approach is combined to get the desired output from on there. There an example is applied for the transformer coupling where two transistors, one is the Q1, that is the NPN type of transistor, and another one Q2, also another one NPN type of transistor, is connected, and the output is come out from the transformer secondary coil. And to get the output on there, the full wave is coming for the input one signal on there. And that time when the one is as a on phase, the another one is the cutoff phase on there. That is the input transformer thus convert the input signal to two output of phase signal for the two NPN transistor. The output transformer combine the signal by permitting the current in the both direction even though one transistor is always cut off. Complementary symmetry transistor, in this case figure shows that the most popular type of push-pull class B amplifier where two emitter follower and the both positive and negative power supplied. This is the complementary amplifier because one emitter follower uses an NPN transistor and other one is the PNP. Look that this is the NPN and another one is the PNP type of transistor is used on there to get the desired output on there. When the DC base voltage is 0, both transistors are cut off and the input signal voltage must exceed VB before a transistor conduct. That means in this region V of P, if it is coming on that, after that one you got it the output below this voltage for the next one transistor. If it is value is the less than the minus of VB, that time only you got it the output for the another type of transistor. And the combined form, if you look on there, that time there and condition will become where no output will become on there. If you consider for the section in here where no signal is come out, and this region is, or this kind of formation is denoted as crossover distortion. So how can you overcome this one? This one can be overcome by using the biasing adjusted to just overcome the VB of the transistor. How it can be? The circuit is provided where if you consider the R1 and R2 the positive and equal value, and negative supply voltage force the voltage at output point A to equal to 0 and eliminate the need for an input coupling capacitor. When the diode characteristics of D1 and D2 are closely matched, look that for the D1 and D2, if they are closely matched to the characteristic of the transistor BJ junction, the current in the diode and the current in the transistor both will be the same here and there, both will be the same on there. That means it will be work just like as a form of the current mirror, and that time the AC operation will be, or AC operation formation will be as such. Here the IC will become, here IC will become for the due to the reason of V of C as such. Okay. So in class A, the Q point is near the middle and therefore the significant current in the transistor even with the no signal. But for the B, that time what happened? When the no signal, the transistor have only a very small current and therefore dissipate very little power. Thus, the efficiency of the class B amplifier can be much higher than the class A amplifier. Okay, so here single supply push pull amplifier we are considering. What happened on there? That time V out will be equal to V of CQ, that is the Q point current for the VC, and that value will be V of CC by of 2, and I out peak will be VCQ by of RL. Maximum output power will be, then what happened? Already we know that power is defined the multiplication of current and voltage. So P out will be defined that I out as a RMS value multiplied with the V out in a RMS form. If you put the value on there, that time the value will become 0.5 IC saturation current for the VCQ. If you apply there, this is the 0.707 is 1 for the RMS value of I out, that is the I out peak by of root 2. So you just decimal value is applied on there. If you put the value for getting the P out, that time this value will become as 0.25 IC sat for VCC, and the DC power supply which is applied on that, this is the ICC into a VCC. So if you ratio between them to get the efficiency one, so that time what happened? PDC value you just applied the in the saturation current form, and then this is the P of DC also calculated into the IC saturation VCC by of pi. If you put this value individual one for the calculation of efficiency P out and P of DC for getting the value of efficiency, that time the result will become 0.25 pi, or it is 0.79, or percentage form maximum, this one percentage form will be 79%. And last classes we already saw that for the fixed biased condition, their Class A amplifier efficiency is only for the 25%. There is 25 and where, and this is the 79%. So which one is the higher in? So here class B type, and obviously formation with the push pull, their efficiency is much better rather than the class A type of amplifier. So for amplification process, their class B amplifier is so effective rather than the class A type of one. So today class is thank you, and we again meet together for the next day for new topic. Thank you.